Trigonometry, Chapter 1, Trigonometric Functions, Section 3, Trigonometric Functions, Video 5, Example 2 of the 6 trigonometric functions. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. We're not going to start with the definitions because we've hammered them a lot, but you do need to know them. Let's start with suppose 3 comma 1 is on the terminal side of theta. Find the values of all 6 trigonometric functions of theta. It's not necessary to draw a picture, but it never hurts. In this example, we're given x equals 3 and y equals 1. We do need to calculate r for these 6 trigonometric functions. Well, for 4 of the 6. Well, r is just the square root of the sum of the squares of x and y. So we can just square 3, square 1 to get 9 and 1, add them to get 10. R is the square root of 10. And notice that we cannot simplify the square root any further. You could try, but the problem with it is that the only way to split it is the square root of 2 times the square root of 5, and neither one of those can be simplified. So no square root of 2, no square root of 5. We're stuck with the square root of 10, but that's okay. Now that we have x equals 3 and y equals 1 and r equals the square root of 10, we can take all 6 of our trig definitions, which you need to have memorized, and make all the substitutions. If you're taking notes, and I recommend it, I would pause and see if you can write them down. Don't worry, you'll have a new problem at the end to try on your own. Excuse me. And when we substitute the values, we get something like this. Again, pretty straightforward substitution. Just be cautious. The most common mistakes people make here is they are careless and they put numbers in the wrong place. And of course, their definitions. All the x's became 3, top of cosine, bottom of tangent, bottom of secant, top of cotangent. All the y's became 1, top of sine, top of tangent, bottom of cosecant, bottom of cotangent. All the r's became square root of 10s, bottom of sine, bottom of cosine, top of cosecant, top of secant. I do want to remind you that if you're having trouble memorizing these definitions here, memorize the top 3 and memorize your reciprocal pairs. Now, whenever you set up these fractions, you're looking for things to simplify. 2 of these should jump out as obvious. Namely, cosecant is the square root of 10 over 1, while over 1 is unnecessary, so that can just become the square root of 10. And of course, 3 over 1 for cotangent of theta is just 3. So definitely clean those up. But you may not know that there's more that can be done. Whether or not you're expected to do it depends upon your professor and the homework platform you're using. I'm going to expect this of my students. The 2 answers that some mathematicians take issue with are sine and cosine. Not because they're sine and cosine, but because they have a square root in a denominator. There's an old school of thought that says leaving a square root in a denominator is quote unquote unsimplified. There are some times where simplifying it doesn't really get you much, but your homework platform or your professor might require you to rationalize the denominator. So we're going to fix this by rationalizing the denominator. And the easiest way to achieve this is to multiply both sides of each fraction by the given square root. For example, let's take a look at sine of theta equals 1 over the square root of 10. What would happen if we multiplied both sides of this fraction by the square root of 10? Well, first off, the fraction in red is equal to 1, so multiplying by it doesn't change the value of the fraction. It simply changes its look. Well, on the top, 1 times the square root of 10 is the square root of 10, and on the bottom, the square root of 10 times the square root of 10 is the square root of 100. But the square root of 100 is just 10. In fact, anytime you multiply a square root by itself, like in the denominator, they basically cancel, and you're left with just that number. This would be the answer that some homework platforms and some professors would expect. And similarly, for cosine of theta equals 3 over the square root of 10, we can rationalize the denominator by multiplying both sides of this fraction by the square root of 10 over the square root of 10. On the top, it would give us 3 times the square root of 10. On the bottom, it would give us the square root of 100, which again is 10. It is worth pointing out that sometimes at this juncture, some more reducing can happen. For example, if this 3 were a 4, it's not. But if it were a 4, then the 4 and the 10 could reduce. All right, now whether or not you need to rationalize denominators depends on the preference of your professor or your online homework platform. So if you're not sure, ask. Now you try. Pause the video and try the following problem, singular. Suppose -2 comma -3 is on the terminal side of theta. Find the values of all 6 trigonometric functions of theta. All right, here's your warning. If you haven't paused the video yet to try them, you're about to see the solutions. Solutions in 3, 2, 1. Like the example earlier in this video, 2 of these did have their denominator rationalized, sine and cosine. It's not always those two, but, sometimes it is.